Thank you. Welcome, and I'm very happy that so many has joined me this morning, this hot morning. I will talk about performance. I'm going to show you how you actually could instrument your code using JDBC features. And my last company that I worked for, Every, which is, I think is one of the three largest Scandinavian IT companies, they actually implemented and defined this kind of instrumentation as a non-functional requirement. And I really think that's a way you should go. I'm hopefully going to show you a method of how you actually should work with performance and how to analyze performance. And I'll be using Oracle. That's my main database that I work with. But I think the ideas here and the concepts here, you should actually use whatever database you're actually using. So, okay, my name is Lasse. I work at a small company called Right in Norway. And this might sound like a very strange question to ask you guys, but how many of you are developers? That's what I thought. That's what I was afraid of. How many are DBAs? Actually, two. You have been. Okay, that was supposed to be my question. Have been or are or have been a DBA. But that's good. So this is not the picture. Now we are three cats. So I hope this presentation is not going to end up like this. Last week I went to JavaZone and did the same talk in JavaZone, and I did survive. I'm going to do this one now, and at 11 o'clock I'm going to do the 10 mistakes the Java developer probably will do if a DBA don't assist you. So just, I'm not going to talk a lot about myself, but just to kind of explain where I come from. And because I'm gonna say a lot about the term DBA, because that's actually a term that I hate. So I actually used to work as a DBA, and I was very early introduced into performance issues. And I kind of became an expert and was always there where there was a task force solving the issues. And just about in 2005, I was hired at this company called Every. And after a while, I realized that I couldn't just stay in operation because there was really nothing I could do there. So I switched job internally and started to work with developers. And for the last 2-3 years, I've been working in payment with the financial services of Every, working mainly together with the Java developers. Sorry. I have been working with SQL Server, I have been doing Oracle, I have been doing Informix. I'm not religious. I think you should use a database that suits your purpose. It could be a NoSQL database, it could be Hadoop, whatever. I do know some Java. I was actually introduced in Java, I think even before this timeline. I had a friend at Stanford University that in the beginning of the 90s sent me a Java compiler and said, this is going to be hot. And I guess he was right.
Hotspot.
Yeah, that's right, hotspot. I think it was more like coffee back at that. Okay, I just became an Oracle ACE associate, and I just quit my job at Every and now works at a small firm called Right. And this is some of the customers that we actually have in Norway. If you need to get in contact with me, this is my contact information. Just scan the QR and this will show up. And I live in Bergen in Norway, on the west coast of Norway. And actually Bergen is kind of like Copenhagen, a very cozy town. And if you go down here by the shore, you will actually find places like this where you could just sit down, have a beer, relax, and yeah, that's true. And the trouble is, the difference between Bergen and Copenhagen is that you can only do this 6 days a year. The rest is going to look like this. So, And actually, we get a lot of tourists coming to Bergen, and they actually come there to see the rain. And they actually call us nerds. I don't know. Okay, so let's get started. Let's just start with a game. Have you seen this before? This is the game of Waldo. And what's the point there? Yeah, you're going to find Waldo. That is this little guy. And there's no prize, you know, just the honor and glory. Could anybody spot Waldo? Yeah, not the big guy. You see the other one? You're pointing up here? Really? This guy? No, that's not Waldo. Ah, excellent. Honor and glory. What in the world do this have with performance? If working with performance actually feels like this, it's a good chance you're doing something very, very wrong. And actually, I find that a lot of DBAs actually do work like this. And that's in the best case. That's the good scenario. I'll show you the other scenario pretty quick. So my quote of today is that performance is a feature. And this next slide, you're going to think is kind of strange, because then I ask, what is performance? Well, I just told you, performance is a feature. But let's just go beyond that. Just think about it. What is performance? Let's just say that we have this situation. You, the developer, are calling your DBA. Do you actually see this? I think that the white was stupid, but okay. He's saying, we are having a performance issue. Could you have a look at the database? And I'm sure you're going to have heard this before. Nothing is wrong with the database. Everything looks green. You know, I've heard it so many times. But the thing is that the developer is talking about performance, but the DBA is actually talking about something else, and it's called capacity. And what he should have said, or could have said, is that I look at the database, it has still more capacity, so there must be something else than a capacity issue. So they are somewhat related, but actually very different. And so this is really nothing to do with performance. And I do want to warn you, because you could actually hit this other kind of DBA that would actually answer this. Okay, I'll have a look into it. And 5 hours later, he called you up again and said, hi, and you kind of hoped that he had found anything, and asked, yeah, did you find anything? And he said, yes, I made a list of 10 actions. I've sent you these by email. Have you heard that before? Yeah, the list of 10 things you should do to improve your performance. I promise you, 6 of those things have nothing to do with your issue. 3 of those things might, and I say might, have a small influence on your issue. And one of them is probably doing just the opposite, making things worse. So my advice, if you get a list like this, throw it in the trash, don't even read it, and get somebody new. This is not about performance. So performance is the time it takes for a computer software to perform whatever task it is told to do. And the task here is the business unit of work. And this is something I thought of this guy called Carey Millsap, so this is not something new. And let's just look at these two terms, time and tasks. And actually, you could just put them together and say time divided on task. Or you could take the task and divide on time. And the first one is equal to what? It's bad. It's equal to excellent. Yes, it's equal to response time. And this one is equal to throughput. And this is what performance is all about. If you cannot say anything about response time or throughput, you're not really talking about performance. How long does it take to actually complete a task? Or how many tasks could you actually compute in a certain amount of time? They are somewhat related. You know, you're all being on a highway, standing in a line, and when the throughput goes down, the response time goes down. But it's not a perfect correlation here. Oh, I just... Who cares about response time? I'm sure you do, but who really cares? Who suffers from response time? It's the users. Okay, who cares about throughput? Your manager probably. Yeah. If the throughput also kind of what do you call that? Yeah. Affect your response time, it's going to be the users too. Okay, so which one would you choose? You could choose between two different, this is average response time, and let's say that your SLA is 1 second. And you have to choose between an average response time of 0.998 seconds and 1.025 seconds. Of course, you would probably say, I would go for A. That's the quickest one. But if you look at the numbers behind these, you would actually see on this left side a lot of red numbers. And customers really don't care about the super fast timings. What they feel is the pain of these outliers. So customers, they don't feel the variance, they feel the mean. No, sorry, they feel the variance, they don't feel the mean. So looking at averages is something you really shouldn't do when you talk about performance. And think about it, where does that leave us? Well, what would a proper response actually be if a developer called a DBA and, yeah, probably or hopefully he would ask something like this: what is the current state? What is your performance issue? What is going slow? And how slow is it actually going? And he would probably also ask, how, this is a dangerous question actually, how fast do you want it to go? You know, you might not gonna be able to, oh, could I choose? Well, I want it to in fraction of a second. But you actually have to ask that. How fast do you want it to go? And I'll show you in a second. So let's say we have this feature called payment list. I work with bank and finance, so we have this feature where you have to list all your payments. And if this thing was going slow, the only way to actually tune this or make it go faster would actually to follow your code path. And knowing all the different bits of times, you could actually find where do I have to make things go faster. The trouble here is I cannot draw an image like this because there's going to be so many back and forth here that, you know, it wouldn't be readable. So, but if I could just put this together and make a time profile just like this. So, the question is now, where would you do your tuning? Anybody? On the server, on the top, yeah. That would be a reasonable place to start, because most of your time is actually spent on your application server. But, as there's always a but, it kind of depends, doesn't it? Because we haven't stated the goal yet. What is the goal? What if the goal was we need to tune only 0.37 seconds? Well, I couldn't really tell you where to start because I still need more information. I need to... Oh, that was the wrong button. I need to know something about this. How expensive is it? And changing the code would probably be very expensive to do. Buying new OS or hardware, that's always the good thing to do. Manage to, oh, let's buy new hardware. Well, maybe it's a medium kind of cost, but if we actually could tune on the DB side, making a better access path, if that is possible, I don't know, it would be very cheap. Just make a new index, do less I/O, do less logical I/Os. So tuning 0.37 seconds, I would actually probably start here. But what if I had to remove 2.37 seconds? Well, I would probably start off there, but I would have to go further up. Okay, so now we have a kind of idea of what I think about when I talk about performance. And once again, I tell you, performance is a feature. So what do I really mean by this? Well, I mean that you should design, code, and instrument your application to actually earn performance and scalability. It's not something you could wait with to afterwards. It's not something you could call up your DBA and say that, hey, I need you to look at my database. I need it to go faster, because it probably can't do that. So just let's jump into the instrumentation part, and this is about filing this Valdo. And we need a way to actually spot Valdo very quickly. And we realized that this had nothing to do with performance. So I'm gonna give you another quote, also by this guy called Kerry Millsap, and he states that performance is not an attribute of a system, it's an attribute of each individual experience with a system. And this notion here, each individual experience, is very important. So let's go back to that sequence diagram. And you guys, you do instrumentation, you write to logs. But the trouble is that you stop just about here, just right in the front of the database. And you might have a log that looks something like this. You write when your payment list starts, maybe. It's an initialization line. And further down, you write the payment list. Yeah, you're going to hit the data access layer. And when it finishes, you write in your log, it's completed in 1.81 seconds. And further down, you might write, okay, your payment list completed in 5.37 seconds. And what is very important here is that you actually put in this little thing. And this is the client identifier. This is the user experience ID. So this is one part of the method that I'm actually going to show you now. Because that's what performance is about, that push on the button. But to actually have that profile, you're missing a very important piece. It's going to be like a black box. So let's just set ourselves, let's just be the DBA for a while and say, what could the DBA possibly do for us? Well, this is we have a lot of views in the database that actually I could start looking, but that would be just as the Valdo game. I would just start looking around to see if I find anything. And if I look into the $V session, I would probably see 200 sessions not having a clue where the ones are coming from. What are running? Is it the payment? Is it some other application running? I don't have a clue. Where should I start look? That same with the $V SQL, where all my SQLs are stored, the execution plans and the SQLs. I just don't know which SQLs are tied to my payment list, or of course I could start to talk to the developer, and that would take a lot of time, but it does work. So how do your database or application actually connect to the database? And of course it connects through a connection pool. And just let's look at, you have this application. This is kind of funny because I'm being a database guy. I actually draw this, and afterwards I realized, shouldn't this be the other way around? So, you know, just a viewpoint. So, okay, this is the application server. I fire up a connection pool with 10 default sessions toward the database. And let's just look at one of these sessions. This line represents one of these sessions. We have these three features in our application that's called payment create, payment read. That's probably the same as payment list. And we have the payment historic read. The definition of fast is the response time has to be less or equal to 2 seconds. That's for the payment create and payment read. And for the historic read, to be fast, it has to be less or equal to 5 seconds. So, Mike, he sits on his browser, he hit the payment create, and the application code grabs the session, runs the code, it runs for 1.556 seconds, releases the connection again, and the connection is idle, and suddenly Tiffany comes in, runs payment historic read using the same session, runs for 3.56 seconds, releases the connection, and is idle again, and this goes on. Suddenly, Mike comes in again. He hits the payment historic read, grabs the connection, it runs for 5.34 seconds. By the definition, this is not performance. How in the world is the DBA gonna find those 0.34 seconds to say anything about it? Well, he's gonna have to look at the averages, and it's really gonna be almost impossible to actually find those 0.34 seconds. So now you need to wake up. It's early in the morning, you probably fell asleep by now, but now it's the time where we're actually gonna see what we could do. And you could actually instrument your code using JDBC feature. Actually, there's one feature, so I kind of lied to you. If we look at the JDBC 4.0 specification, they make a new promise. They promise that there's going to be improved connection state tracking. And if we look further down into the specification, if we look at the connection object or class, we see that there is going to be another method called setClientInfo. And if you look into the Oracle specification of this, you actually can do something like this. Your code grabs a connection from the data source. That's the session. And then you could actually set on your connection 3 different tags. It's actually, I think there's some more, but these are the 3 basic tags you could set. A client ID, module, and action. This is Oracle related, but in different databases, it could be something else. I don't know. I work with Oracle. So then you could run your application code. And at the end, you close the connection. And when you do that, these are also closed. They're reset to nothing. You could, of course, implement this in a more fashion way. Like this guy called David Carlson, we were using web services, and we were using the Spring framework. So when he, from his client application class on the DAO layer, when he called get connection, he would actually just call a Oracle end-to-end metric data source wrapper was an implementation of a delegating data source. And the data source wrapper actually just asked a context resolver about what is the name of the web service, and put in a user and a client ID. But it doesn't matter. You're developers. I'm sure you're going to find a way to actually do this. To actually use this specification, you need to at least be on the Oracle JDBC 6 or above. And now a disclaimer, because we're going to look into Oracle. And if you feel any discomfort, please don't leave the room. Just look away. It only lasts for a couple of minutes. So, Oracle has this thing called Oracle Trace. And what Oracle Trace is that on a session, you could actually turn on trace. And what trace do is that it writes all the OCI calls made on the client side to a file, and it does that after it actually happened. So it also writes a lot of statistics. And if you might recognize, it does a parse, it does a bind, and it does an execute, and it also does a fetch. And the fetch is where it actually gets your rows. And if you see here, I could see some statistics. This fetch actually spent 50, that's not, this is microseconds on the CPU. The total elapsed time was 84 microseconds. It did 12 consistent reads, which is logical reads, just reading Oracle blocks, and it just read one row. It fetched one row. So it gives you actually a lot of statistics. On the bottom here, you will actually see a wait, and this is where Oracle is actually doing nothing. It's just waiting for something. I don't like the term wait, because there's actually not a wait. It's something is going on. But okay, it's not Oracle doing it. It's doing an I/O, and this is a DB file sequential read. So it has read an index, and it wants to get a block, because on the index you find the row ID, and it needs the block. And this is the block that's read. The elapsed time, that's 53 milliseconds. Okay, this is on a session. So if you think back, we cannot actually use this, because we're only gonna see a lot of averages here. So, okay, that's gone. But what if the code was instrumented with the set client info? So this is gonna define the method. This is how you actually should work with performance. And it kind of relies on you guys, because I cannot do this if you haven't actually implemented set client info. And that's why we actually done this as a non-functional requirement in every. So this is what in Oracle we call this Oracle end-to-end metrics. And these are those three tags: module, action, and client. It's 64 characters you could put in, or actually back in 10 or 11 or 10, there were actually less, but you're probably going to be on 12 right now. And on 11, there is an underscore parameter you could set to make it 64. So what do you put in these? Well, you could put whatever you like, but I suggest that you do something like this. In the module tag, you put the feature in action. Like in my case, it was the payment list. In the action tag, you could put the username, because this way you could actually trace only one user. Tom Kite was once asked, well, what is the cost of doing trace? Because it has a cost, if you're going to trace something and write to a file, it surely has a cost. And he answered, well, it has a negative 25%. And this guy was, a negative 25? Is it that negative? No, it's a negative 25, so it's positive, because without knowing how fast you're going, it's impossible to actually adjust your speed. So yes, trace is a little overhead. It's not very much. It's actually very little. So don't be afraid, but okay, we could just narrow it down to one user, and maybe the user that actually had this issue. And then we introduced this unique identifier. And in Java, you could easily do that by doing a UUID, random UID. So it's actually very easy to actually generate one. And this would actually help the DBA a lot, because doing this, he could actually now go into the select star from read session where module equals payment list and action equals this user, or maybe just this part. So now we could actually see which session are running what kind of features. Actually, now you have something to talk to the DBA about. That's just worth a whole lot. Okay. And the best part is that you could do a select star from read SQL and actually see what is going on here. And this is pretty neat. I heard you were using Hibernate. You really need to know what's going on behind the scenes. So this will actually show you all the SQLs that your feature actually fired towards the database. So, and there's a lot of other views that actually show you this. But okay, let's move on. So let's say you did this. You didn't put the literal in, you know, of course not. You just put you put in the payment list. You put in Mike. When you hit that button, your application was running and you closed. So on the database side now, I could actually trace on turn on trace based on those metrics. I could do like DBMS monitor, serve module act trace. That doesn't matter. I could turn on trace on payment list. Only that, or I could just do tracing on Mike. So when Mike came in next time, Mike clicked the payment list button. Your code set the metrics. I have turned on trace for payment list and Mike, so the trace file is written. You also write that identifier to your log with a timestamp that says that run for 9 seconds. You know that is slow. In the trace file, you actually also see this. So all your trace information is actually preceded by this. So now you could actually call your DBA and tell him to do this. Well, he used a tool called trace session. So he'll make a new trace file where he filters out only the information based on that push on a button. So then we could use a tool. This is a tool called Method R Profiler. There's plenty of other tools that you can make a report from that trace file. And this is just a small part of that report. And what is that? Well, this is the time profile. Where is the time spent inside of Oracle? This is the missing link. Now I could actually see the total time spent in Oracle on that push on a button is 0.278 seconds. So if the total time was 9 seconds, it could definitely not be the database. I could actually call back and see the database is green. No, I would actually say that, well, this push on a button is not, the 9 seconds is not caused by the database. It's actually only spending 0.278 seconds. So you have to look in your code somewhere. But let's say that this was almost 100% of your time. So almost all your time is actually spent in the database. Even down to this very quick response time, you could even tune this. You could just go on the top here and see where is most of my time spent. Well, it's spent on reading IO. And here you see the call count. I called 3 IOs. The mean time is 42 milliseconds. That's kind of slow, I would think. And there's only 2 ways to actually tune this. What is those? You could either remove the call counts by not doing the IO, or you could reduce the mean time. Only 2 ways. I could do both, or, well, if I removed it, I wouldn't have to do that. I could buy new hardware to make my disk go faster, or I could actually put this in memory. I could pin this in memory, so it never would actually have to do it. And all this would just go away, and I would almost have the half of the response time. This is the way you actually should work with performance. Just get rid of this black box. And think about it. You are developers. You could probably easily make something like this. Just an interface and a table behind somewhere where you list your features. You could actually just hit the edit button and turn trace on and off, whatever. If you just wanted to trace a specific user, you could just put in the user you just wanted to trace. When you have traced for a while, you could hit the file button to actually get the trace. A new screen would come up, and you could put in your client ID if you just wanted one client ID. If you just wanted to see everything, that's fine. But if you just wanted this file, hit the button, and you have a file, one click of a button, and you could actually give that to your DBA and say, I need help on this. So if you're in test and development, making a new feature or doing some changes on your feature, turn trace on, run it for some times, get the file, send it to your DBA, say, hey, I want you to analyze this. And then the DBA could actually do something for you. So how would this work in production? Well, now we have a totally different setting. The guy is calling, we're having a performance issue. Could you please turn on trace for payment list? And hallelujah. So finally, we could actually use the DBA for something. And he would say, okay, sure, I just turn on trace. And 10 minutes later, you just find some IDs in your log, and you call back and say, I found this client ID. It's taking too long, and it's spending 75% in the DBA, because you maybe have that in your logs. And this guy would say, okay, hang on. And, 5 minutes, he has made his report, showing that 90% is spent on blah, blah, blah. And we could either do, or we could actually do this. Oh, sorry. So, performance is a feature. Instrument your code using JDBC feature, it really makes the difference. Whew. Still awake? Okay, that's good. This is kind of a small peek into what I'm going to talk about in my next session, starting at 11 o'clock. And that's the 10 mistakes the developer probably will make if the DBA don't assist. And when I said performance is a feature, I said that what I mean is you have to design and code and instrument your application to earn performance and scalability. So I'm just going to show you something that happened in every, that actually, is about design and how you actually shouldn't design your code. It's just going to be a peek into what's coming in the next hour at 11. Or at 11, I'm going to show you 10 different mistakes you could do. But maybe the most important part of that is actually I try to show you how a relational database actually work, and how you maybe could change your thoughts of how you actually code towards a relational database. If it's SQL Server or Oracle, I don't think it really matters. So, okay, this was the setting. They were rebranding the payment solutions. They stored the data according to a new standard called SEPA. Is a ISO 10022 thing where you kind of, a payment, an international payment is defined certain ways. And these were the three main tables. It was a header, like a payment header. And a header could have a lot of different executions because, yeah, you could store together a lot of different payments. And a payment could actually be to different accounts. So there's a execution could also have a lot of different instructions. And the interface here was, the client side was either online or it came a file in, an XML file. And it was processed by a Java layer, a web service, and on the database side it was Oracle and using some PLSQL on the database. So what the coders did is that they wrote something that actually worked. It had the functionality. They did an insert into a header table. They looped on the execution, did an insert into execution, and they looped on the instruction part and did an insert into instruction. And of course, it did work. It was the requirement specified in the requirement specification, but could we do any better? Databases, if it's Oracle, if it's whatever, is not very good at doing many small things. That won't scale because there's an overhead in every single SQL you're firing towards the database. So doing the online, well, it wouldn't be pretty bad. It would only be 1, 1, and 1. That's only 3 inserts. So that's not bad. Well, in a second, I will show you that, well, this is also bad. Okay, but we'll get back to that. But the file thing was a disaster because, well, it could do 3, but most times is I actually had to do thousands of inserts, and it would actually never scale. I could easily, just by reading code, say, this won't scale. So this being a PLSQL, using PLSQL, I could very easily like rewrite this. So I made a type, instruction, like a object, a class, that contained the variables for instructions. And I made a collection type that could actually be a table of instructions. So I did the same thing for the execution, had the execution variables, and also had a pointer to a collection of instructions. And I made a collection class, or a collection of tables of execution, and in the bottom here, I made the header that had the variables tied to the header and had a collection of execution. It's just a tree, just like an XML. So my pseudocode would be something like that. The insert procedure would take a header, a tree structure coming in. I would define execution collection and instruction collection. I would loop through, build up these collections, and in the end, I could actually only do 3 inserts. I could do an insert into the header. I could do an insert into execution based on a select from collection, because collection is just a table. In Oracle, that was very easy, because I could actually just do this: insert into header, insert into execution, select from table the header, and execution. And this is just a table of all my execution. I could take the variables, just insert. And even going further down, it was very easy, because I could only do an insert into instruction, select from table, execution, and I just said that that is a row with all the executions, and for that row there is a collection of instruction. So if I join those, I would actually end up with all the rows for instructions. So I could very easily, very quickly, change this code, and it was scalable, because instead of doing thousands of insert, I now only did 3. It didn't really matter how many was coming in. That is scalability. So when you look at this, does this have some other effects on the system? Yes, it certainly does. Because when I am going to read this payment, I have to go through that tree. I have to read the payment, I have to read the executions, I have to read the instructions. So, if I look at how is my data now actually fragmented, how is it clustered? So I did 10 sessions on the same time. Each session was running the insert header 100 times. It was 10 execution per header, and it was 100 instructions per execution. So just doing a bunch of data. So afterwards, I did a group by header, and I found the block number that actually gave me which blocks do I had to go to actually read that data. And I found the minimum, the maximum, and the average. On using the for loop, my maximum count to read one payment was actually 33 blocks. And on the average, I had to do 12. If I did this the collection way, I had to reduce the maximum count down to a third. And this being a heavy load system, that would actually make a whole lot of difference. And the average was down to half. So I actually released the burden on my database with the half. And this is also about response time. This was probably going to be so quick anyway, but it's still there. And people complain that Oracle license is expensive. If you give me 1 month, I could actually reduce that, but actually make things, because you pay by CPU. And this is nothing other than CPU. You're burning CPU. Maybe you also burn some I/O. I don't know. So let's go back to the online things. Let's say there was a requirement. I don't remember the requirement actually, but let's say that the requirement of doing 10,000 registration per second. Because this is payment, there's going to be a lot of payments coming in at certain time of day. And if I was going to do 10,000 registration, that would be 30,000 inserts, and it would be 10,000 commits. And I had a feeling, I don't think that will scale. You know, so I have to do a proof of concept there. So I just did this on my laptop. I did 10 sessions doing 10,000 registration, and well, it finished in 39 to 40 seconds. That's about 2,500 per second. It did definitely not meet my requirement. So I just did a proof of concept that this won't work. And you know, we were lucky that I discovered this very early, that I actually was in that project to see that, because we would have to rewrite the whole thing, or actually in this case it was pretty easy. So what if and this was this other guy talking about, what was the name of that presentation? He also talked about how you need to batch up things, and this just is another example. You need to batch up. So what if I could do 100 registration in a batch insert? That 10,000 would actually now be 300 inserts. So I could do something like that. I could introduce a queue layer or Java zone last week. I went to a Kafka presentation. Maybe I could use Kafka because that's new and cool. You know, it's just a way to try new things. I don't know. I don't care. But if I just could store all those down to a layer, and here I could actually scale very easily because I could just put on another server, you know, because I need to just push this away somewhere, and my Java code could just pull every hundredth of a second. It just pulls 100 new ones and do the batch towards the database. And when I tested this, the same thing ran in 8 to 9 seconds. That's 11,000 per second. Hey, I'm there. And this just shows that performance performance is a feature. You really need to code and design. And the instrumentation part is going to give you a tool how to work with performance, but the instrumentation is really not going to fix your issues. It's not going to fix your code. So my point is that you have to use the right kind of resource. If you're doing a small application for your neighborhood membership in diving, it wouldn't matter. But if you're working on a system that really needs to scale, you need to use the right resource. And it might, I'm sorry to tell you, it might not be it, or you know this, it's probably not a DBA. And at the end, it's you know, this is what I tell my manager, you know, you get the system you deserve, and then it kind of steps back. Oh, really? Okay, maybe we need that kind of resource, because there is really no magic. And on an open world, I think it was 2 years ago, I went to this presentation about Hadoop. And I think it was about scalability, how to scale to infinity. And the next session, I went to this presentation with, I think it's called Tim Gorman. It's a great Oracle guy. And one of the people that also joined the Hadoop, he kind of, before the presentation started, he asked, well, can Oracle actually scale to infinity? And Tim just stopped for a second and just thought about it, and I didn't think he actually was going to answer that. But suddenly he just turned to this guy and he said, yes, Oracle can scale, but you can't afford it. So, but on the bottom line, you get the system you deserve, and don't forget to push that button. Oops, okay, I didn't mean that to happen, did I? If there are any questions, I'm very happy to answer them. I think there are 2 minutes left on the presentation. These are my contact information. I will stick around for the day, and I'm also going to do the presentation at 11 o'clock. I will be very happy to see you there, and thank you guys. Any questions? No?
Do you have any information on what other databases can make use of this set client info?
I knew that was coming, didn't I? Everybody heard that? Yeah, he asked databases has this the same use. Well, I don't know. No, I haven't had the time to actually check that. All the other databases is not they are complete. They change them all the time. So if they haven't, you should ask for it. You know, it shouldn't be too hard because they also have a lot of information on the back of the database. They have like dynamic views. So if they don't by now, maybe it's time that they actually implement that. Yeah, it is in the JDBC specification, and actually in Oracle, you actually could do this before the 4.0 specification, because they had some functions on the Oracle connection that was called set end-to-end metrics. But finally, they made it a part of the JDBC specification that actually made it a part of the specification. So hopefully, there's going to be more databases systems that actually going to do that. Postgres, you can do that. Excellent. Perfect. I didn't know that. Thank you. Thank you.
How about actually getting the matrix back from the database into our world?
Yeah. It would be kind of pushing a load into, so I wouldn't do it on a regular basis, but if they are there, so I'm sure, I mean, this friend of me, Kari Millsap, actually has become a friend of me, and what he always tells me, it's just code. You could just code it. I mean, it's possible. Yes? I think that we need a glass of water. So let's do that. Thank you.